Hi everybody, in this video we're going to continue looking at integration with substitution, but we'll only be looking at functions that involve some variation of e to the x. We're going to start with the integral of 5e to the power 1 over x divided by x squared dx. Luckily, we have some rules when we get to e, and the one I'm going to talk about right now is having only one e. When that happens, I grab the exponent and that's going to be u, so u is going to be 1 over x. We could also write that as x to the negative 1, and what we want to do is take the derivative. So the derivative, du, I would bring the negative down, I would get x to the negative 2, and then dx. We could write that as negative 1 over x squared dx. So when we're doing substitution, we always want to start with what is u, we're going to take its derivative, we're going to get du, and then we'll look at what we started with. So I'm just going to break apart this negative 5e to the 1 over x divided by x squared dx. And how I'm going to write it is I have the integral, I have a negative 5, I have 1 over x squared, I have e to the 1 over x, and then I have dx. I'm going to say this 1 over x, this is going to be my u. This negative in front of the 5, along with the 1 over x squared, and also along with the dx, those three parts become du, and then I still have the 5. We have a 5, we have e to the u, and we have du. Now that we've changed it over to 5e to the u, we know the integral of 5e to the u is 5e to the u plus c. U was really 1 over x, so we're going to write that as 5e to the 1 over x plus c, and we finished. Our next one also has an e, but notice this time it has two e's. I have 3e to the 3x times e to the 3x minus 9 to the 4th dx. This time I have two e's. So I look for what looks more complicated, and what looks more complicated is this parentheses, where it's e to the 3x minus 9 to the power 4. So I'm going to just take this part, the e to the 3x minus 9, and that's going to be my u. Then I'm going to take the derivative of that. So the derivative of e to the 3x is e to the 3x, and from the chain rule I have a 3, and then I write dx. Now let's kind of compare. Well, what do I have? This 3e to the 3x along with the dx, that's going to become du. And then the e to the 3x minus 9 is going to become u. So I have u to the 4th du. When I integrate, I get u to the 5th over 5 plus c, and then we substitute back in that u is really e to the 3x minus 9 raised to the 5th power divided by 5 plus c. Remember, another one that has two e's. I have e to the x plus 2 divided by e to the x plus 2x dx. So two sets of e's. I know one of them is going to be the u, and I look which one is more complicated, and it's the denominator. So u is going to be e to the x plus 2x. The derivative of that is e to the x plus 2, and we remember to put a dx. When I substitute the whole numerator along with the dx, that's du. The denominator is u. I'm going to write that as 1 over u du. So how do I integrate 1 over u? Hopefully you go, oh, you do ln, and that's what we're supposed to do. So we do the natural log of the absolute value of u plus c. That's the natural log, absolute value of e to the x plus 2x plus c. That is the solution. The next one only has one e. It says the integral of e to the 5x plus 3 dx. So with only one e, we know to grab the exponent, which is 5x plus 3, and that's the u. The derivative is 5 dx. Well, when I'm looking, this e to the 5x plus 3, I don't have a 5, but that's okay. I have the dx, which is important. So I'm just going to divide both sides by 5, which I like to write as 1/5 of du, and that's just going to be dx. So I'm going to go back in, and I have the integral. E, 5x plus 3, that's u. dx is equal to 1/5 of du, so I write 1/5 of du, and I can integrate. E to the u is still e to the u, 1/5 is still 1/5. The du goes away, I have a plus c. back to the beginning, I say 1/5. U was 5x plus 3 plus c. I'm writing this one a little bit different, and this is p prime of t. So think this could be like a profit function. So I might have that the marginal profit is 2e to the 0.01 t. I want to find p of t given that p of 0 is 1800. So I'm starting with, let's integrate. I have 2e to the 0.01 t. Now note I'm going to put dt, so I'm integrating with respect to t, so I always want the variables to match. When I integrate, the exponent u is going to be 0.01 t. Then I take the derivative du, it's 0.01 dt. Here I have the integral of 2e to the u, because we said u is 0.01 t. Now the dt, I don't have the 0.01, so I'm going to do 1 over 0.01 du is equal to dt. So let's write that, 1 over 0.01 dt. Before I start, let's go ahead and put together this 2 with the 0.01. And when I divide by something small, I get something big. 2 divided by 0.01 is now 200. So I have 200, I'm still integrating, e to the u, and this is du. Let's go ahead and fix that, this du up here. Now when I integrate, I just have 200e, then the 0.01 comes back in, and then I have plus c. Now this time I'm going to be able to solve for c because I had an initial condition that says when I plug in 0, so I have 200 e to the 0.01 times 0 plus c, I should get 1800. E to the 0 is 0, so I have 200 plus c is 1800, which tells me c is 1600. So my function p of t is 200 e to the 0.01 t plus 1600. So remember, we can solve for c when we know an initial condition. The next one says e to the 4 minus x. 1e, which says u, is 4 minus x. du is negative dx. So remember, this negative x, when I take the derivative, is a negative 1. You can write the 1 or not write the 1, but I need that negative to pop. So we don't have that negative when I look at the original, so I divide by negative 1. So I have negative 1 du is equal to dx. So when I integrate, I have e to the u. dx is negative du. Integral becomes negative e to the u plus c. So that's negative e to the 4 minus x plus c.